So to reiterate a bit on what we just learned about objects and classes, you can think of it this way. A class is the blueprint. It's not an object, it's just a formless description of one, while the instance is the actual object. And actual objects in the actual real world have to be created somewhere. They have to live somewhere, right? So where do objects in code, where do they live? Well, just as human objects live on plots of land on Earth, objects in coding live on memory sectors, little plots of land on memory chips, right? So that's what happens when you use the new keyword, when you're creating a new object in memory, right? So in your code, you use the name for your object that you created, your variable name, in other words, or your identifier, to keep reference to this object throughout your code that's in memory. And when you make this object reference a field, so a class level variable, remember, you get a very interesting containment structure that I'll show you in a moment. So when we're creating our instance of a class, such as this field inside of another class, we're able to utilize this class just like any other type, int, bool, etc., because it is a type, a user-defined type. So we can achieve this complex functionality in any single class by incorporating or containing references to outside classes in this way. And of course, those classes that are used as fields within another class can themselves contain reference to yet more outside classes, leading to this sort of multi-container Russian doll aspect of more complex containment. And one of the benefits of this feature of object-oriented programming, boxing up entire classes into a single field within another class, is you can abstract away information that isn't immediately necessary to know in depth, which I'll show you in action in a moment. Now, in the previous video, we talked about this class-object relationship using a concept we're all familiar with, a human being or a person, right? But the concept is no less applicable to virtual objects that you might have within your game. So let's expand on our knowledge of classes versus objects with a more game-like example. So let's write a new class here. Let's actually create a new script. And this time, now because it's not a mono behavior, right? So it's not directly embedding into Unity, the class name and the script name can be different, and this will be kind of interesting. Please don't get confused. I'll show you in a moment. So let's call this let's say, I don't know, RPG classes, right? RPG classes, and open that script up. And sorry, get rid of that error message, don't know why it's there. And get rid of mono behavior because we don't need it. Again, we're not going to directly attach it to a game object, as well as get rid of start and update. And let's create our, well, as I said, we don't need to have the class the same name as our script name, RPG classes in this instance, because it's not a mono behavior. So let's just make that reference right here of class wizard, all right? And we don't want to write anything in this class just yet. We just know we're going to want a wizard. And down here, we're going to write a new class, another class. So say public class weapon. So yeah, I didn't want to confuse you, but I wanted you to see it all in one file so it's easy for you to visualize, easy for you to see right in front of your face, all these different classes and how they're related to each other. The reason, again, I'm able to do this, but you're not able to do with mono behavior scripts that attach to game objects, is because this is not directly embedded in the Unity engine right now. We're not deriving from mono behavior. So that's why we're allowed to write all these classes in one file. Otherwise, don't do this. This is not how you're going to be doing things. But we're going to want a weapon along with our wizard class. And Actually, that's it. Just these two classes right now. Let's first define our weapon. Okay, so public, and as we mentioned earlier, public means it's accessible to an outside class to view. And even though this is in the same script file, this is still an outside class. It's its own class. So make the field here public. It's going to be a string, and let's just give it a name. We'll call it weapon type. And we're not going to assign it anything because we're going to want to assign it later when we create the object of our type weapon. So we're going to want to create a method. So make that public as well for the same reason. And usually we type in void, but I'm not doing that here. I'll quickly write out this method and explain in a moment why we didn't write in void, but we wrote string instead. And let's call this method definition use weapon, and just have one line of code in this method, and write in this new keyword called return, and then we're gonna use the quotes to designate a string and glue together with that string using the concatenation plus operator, as we'd used before, the weapon type. And in this literal string, write the player has struck with the weapon of weapon type. Right? That's what's going to append on the end of that. And for a wizard, what we'll do is we'll just give it a single field of type weapon. So public weapon, type weapon, with the name weapon equals new weapon. So we're creating the object in directly within our wizard class, but our wizard itself has not been instantiated yet. So we create a weapon instance in our wizard class. That instance becomes an instance when we create a instance of wizard. Hope that didn't confuse you. We'll see this in action in a moment. So as before, what we're going to want to do next, after I save that, is create a mono behavior script so that we can output to Unity. So create a new script, we'll call it RPG controller, right? In this case, we can't change the name of the script and make it different from our class name within the script because it's a mono behavior and it's being attached to our game object. Actually, before I forget, as usual, I should do that. Going to our test game object, we're going to attach this RPG controller output. It's going to be responsible for outputting to Unity. And here in RPG controller, let's type in this code. We're going to use void start. We're going to use start as usual so we can at least output it, see it in Unity. And in start, we're going to create our instance of our object wizard. So type this in. And then using the dot accessor, we'll access the public weapon. And because the weapon has a field of type weapon type, right? The string field, sorry, not type weapon type. It has a field of type string called weapon type. We'll access that field name by just doing the same as we did before with the dot accessor. And because it's a string, it's going to need some sort of assignment of a string to it. So we're going to give it the string name wand. Okay, so our wizard now has a wand, at least a string called wand. And as usual, output that to our debug log. And this time what we'll do, and we're going to want to reference our useWeapon method found in the weapon class. So type this in. There's useWeapon, nice and handy, available to us through IntelliSense because it's public. And let's output that to Unity, see the message that we get. There, the player has struck with the weapon wand. All right, so this is a bit more of a complex use of everything we've come to know thus far. First, we created a class definition for a game character called Wizard, right? And right now it only has a single field, and that is for a weapon, right? And in this example, we decided to make a custom type for a weapon called weapon. And that class, in turn, the weapon class, contains a string called weapon type, right? As well as a slightly different looking method to ones we're used to seeing. It's called useWeapon here. And finally, we make use of these classes by creating an instance of our wizard in the player controller class that we called RPG controller. And when that instance is created, it creates an instance of the weapon field as we showed earlier, right? We get a new weapon when we create the instance of a wizard. And by using the dot accessor, and with the help of our trusty IntelliSense, we're able to peer into these multiple levels of containment. The dot accessor can be seen as zooming into each set of squiggly brackets, or opening up those containers within containers. So we first peer into what our wizard object holds, right? It holds a single field of type weapon. It's a weapon of type weapon. Then we peer into the weapon it's holding, and we see that the weapon has a weapon type, right? Which is a string. And we also have a method in our weapon called useWeapon. Now I threw in there something new, and that is I had our useWeapon method return a string. But in this case, we want to return the string back to the calling code block. Basically, you can look at it like when useWeapon is called in our player controller, RPG controller, start method, it executes and then returns that string. So it's like opening up that box of instructions, executing them, and poof, after the box executes, it disappears, and in its place is a string of characters, the phrase we wrote in the useWeapon method, right? So this string is being returned to our executing or calling code block. It's returning this string. That's why it's no longer void, right? This is our return type. Void means there's no return. And here where we actually, the calling code block, we expect it to, when we call that method, to return that string, right? And as I said, we determine the return value type right before the method name where your method definition is created. So where we normally put void, we simply replaced it with string. So that's necessary. See, if I typed in void like we're used to, there's a mismatch, right? Down here in our error pane, it says weapon.useWeapon returns void. A return keyword must not be followed by an object expression. All right, kind of, a vague error code. It's basically saying that you can't have something return after that method executes, return to that code block that calls this method. You can't have a return type and then say that there's no return type, which is what void means, right? And it has to be, the return type has to be the same type of which you specify here. So this is a string, and we concatenate at the end of it another string. So that's of type string. So it has to be string. all right, or a compatible type, in this case, string.